So in today's video, we'll be solving smallest palindromic rearrangement second problem. The first problem we solved yesterday. Today it's the hardest problem, and we are given with a palindromic string yes and an integer k. Written the kth lexicographically smallest palindromic permutation of yes. If there are fewer than k distinct palindromic permutation, written an empty string. Note, different rearrangements that yield the same palindromic string are considered identical and are counted once. Which means this note means if there are two A's in our given string, placing it at the first and placing this A at the first and the end makes the same kind of string, right? That will be counted only once. It won't be considered twice. That is what is being indicated in this note. And moving on to the first example, this is the given string and this is k. So here if you look, we'll have two permutations, distinct palindromic regenerations. One is you will place b at the first position and one is you'll place a at the first position. This is where we place b at the first position. So two distinct palindromic rearrangements of A, B, B, A are A, B, B, A, this itself, and B, A, A, B, where we place B at the first position. Here we have only two characters, that is A and B, so only two rearrangements is possible. Yeah. Lexicographically, we have A at the first because in our ABCD character list, A comes before B, right? That's why this comes before B. Since K is 2, the output will be BAAB. Looking at this, we have double A's in our given string and K is 2. What will be the second permutation? Nothing. We have only one character. How much ever rearrangements we do, we'll get the same string. It's the same thing. Only one rearrangement we get, that is AA. There's no second permutation. So we written the empty string. That is what is given over here. So if there are fewer if the arrangements are fewer than k, then distinct palindromic permutations written a empty string. That is what we are doing over here. Written empty string. Now let's visually dry run this problem and understand how to come up with the coding ideology. As we saw in our previous problem, we'll be forming the palindromic string using left, middle, and right. Same like how we did in our last problem. The right is equal to the reverse of left. Now let's take our string as A, B, B, C, C, and K is equal to 4. So the character frequency of our example will be A is 2, B is 2, and C is 2, because it is appearing twice in the given question. That's yes, right? Now take half of it. Take half of the frequency that we have found over here, because we are trying to build the left half first. So our left characters would be A, B, C. We are taking one of each of these frequency. We are getting A, B, C. Now palindrome would be left half, that is this, and the right, which is the reverse of the left. But this is not it, right? We are supposed to find the lexicographically smallest permutation of ABC. So we need to move further, but we are given asked to written the fourth smallest palindromic string. So to find that, the first position, we first of all try to fix the first position with A. But before that, we won't be generating all the permutations. Instead, we count the permutation in groups and skip the complete groups that cannot contain our answer. Yeah, now we first of all fix the position of our character A and try to generate the other possible permutation with the remaining characters, that is B and C. The possible permutations are A, B, C and A, C, B. So the count is 2 because we have 1 and 2 combinations, right? So the count will be 2. Now we are asked to calculate the fourth permutation string. 4 is greater than 2. So we need to skip the block A. That is, we had blocked A at the first position, right? That's not the answer. So we need to change that variable into something else. Now we'll be uh, decrementing K by 2 because 2 of the permutations we already calculated and that's not the answer. So we minus 2 from 4, which is the permutation rearrangement we are supposed to find. Now let's try blocking B at the first position, and the remaining characters are A and C. Now the possible strings that can be formed with these two characters is BAC and BCA. Again, the count becomes 2. Now 2 is less than or equal to 2. So we choose A to be in the first position. Okay, now the confusion is which is the fourth one, this or this, right? So position 2, we fix the position 2. Again, we fix position 2 to be A, and the possible combination is only one, that is C, because the remaining character that we are left with is only C. So we need to fix that C at this blank position. We get the count as 1. So here K, which is equal to 2, is greater than 1. Skip it. Then we need to assign the value of K. How do we do it? We minus 1 with 2, that is the current combination count with the current value of K, and we get 1 as our answer. Okay, then try to put C in the second position. We fix C at the second position, and the only one remaining character is A. We add A at the pending position. Again, the count is 1. So the current value of K is 1. And then when we check 1 is less than or equal to 1, it's true. So we choose C to be at the second position. So this will be our answer, final answer. Okay, so position 3 will be surely occupied by A because when B and C are blocked answers, then the remaining character is of course A. So we conclude this to be our left half string. Okay, now we need to find the right half string. How do we do it? We'll be reversing the left half string and we'll get ACB. This will be our final answer. I hope the visualization is clear to you guys. Now let's move on. If you don't get this, try rewinding it and watch it again. Try to understand it. Then move on to the algorithm part. And also, before we move into the algorithm part, one thing to remember is we need to handle the duplicates as well. So, for example, if our given string is having two A's, like any of the any of the character is being repeated multiple times in our string, then we need to use this formula, that is total by frequency 1. Like if there are multiple characters, then frequency 1 factorial into frequency of second character factorial. Okay, everywhere factorial. You divide the total by the frequency. Total in the sense the total number of characters in the given string, which is 4 factorial divided by how many characters are repeating how many times. So here A is repeating twice, so you divide by 2 factorial. In case here there were 2 B's as well, then you would write 2 factorial into 2 factorial because 2 of the characters are repeating twice. You will be getting 12 distinct permutations. Now let's move on to the algorithm part. First of all, we need to count the character frequency, and then second, store the odd frequency characters as the middle. Like in the example that we saw, all the characters were appearing even number of times, but if there are odd frequencies, then that character you should have to store it in the middle, because at the end we are trying to find the permutation, right? So if odd frequencies are present, then we are going to add those characters in the middle. Then divide all the frequencies by 2, because we are not generating the string all at once. We are trying to generate the left half first and then going to the right half. So you have to divide the frequency, whatever you get, by 2. For every position in the left half, try characters from A to Z. Yeah, that's how you rank, that's how you get the value, like which um, string has to be written, right? Temporarily use one copy. That is blocking one character at one position. That is called temporarily. You have to select a character and count how many permutations can be created with the remaining characters. This we have visualized in the visualization thing. That is what is written in sentence. If the count is greater than k, then choose this character. Otherwise, you have to skip it. Okay, you have to skip as well as analyze, like recalculate the value of k by k minus count and restore the characters. Restore the characters in this sense, try the combination with the next character. Then finally we have to construct the string using left, middle and reverse left, and return the answer. If there are fewer than k arrangements, then return just the empty string. That is it. Now let's try to code this in our code editor. Now we will begin with calculating the length of the string. Yes dot length. Then we'll need a frequency array to store the frequency of the characters in the array string that we are given with. Say freq is equal to new int of 26, because we have 26 lower characters. And then we'll need a string. I think it's fine to declare that string later. Now let's calculate the frequency. See, we only need the characters from the first half, because the given string is already a palindrome, right? So for int I is equal to 0, I less than n by 2, and then I plus plus. Then we need to calculate the index. Int index is equal to yes dot char at I minus a. This will give us the index. You can do it directly as well, wherein you are subtracting I minus a. You'll get the index. You don't have to do it separately, but I will be doing it separately over here. Index plus plus. This will give us the frequency. After calculating the frequency, we need the length of the first half. That is int length is equal to n by 2. Okay. Then we need to check whether at least k different arrangements exist. Otherwise, we have to return an empty string. That is given in the question. Yeah, return an empty string. So if let's create a method function which calculates the number of ways. Okay, let's name it as count ways frequency comma k. This is what we'll pass, is less than k. Then return the empty string. Okay, now let's write the count ways method. This method is basically to count the distinct arrangement using the available characters. So private int count ways, where we'll be passing an array, integer array called freak, and int limit is k. Okay, and we need a long where we'll store the ways. Why is this in long? Because see, permutation is like it can have many numbers, like many count, right? You can't just rely on integer, so it's better to take a long and store and then we need a variable to store how many characters have been processed. Let's name it as used, like how many characters have been used. We'll initialize it to 0 because okay, now some people might have a doubt, why is long ways equal to 1? It's 1 because question can't be empty. That is one of the way that's possible. Ways can't be 0. At least one way will be there. So you can't initialize it to 0. Then we'll need a for loop to move across the frequency array. I frequency. If I is equal to 0, which means the frequency is equal to 0, then you just have to continue. Okay, now we need to create a long variable which is used to choose the position for the current repeated character. So say a long combination is equal to, now to calculate the permutations you need something like NCR. You might have heard this in maths, right? This is also required here, so we'll declare a function later, but now we'll be using it in this function. We'll name it as NCR for our better understanding, and we'll pass used plus combination inside this. No, not combination, used plus count. Okay, count comma count, and then also the limit inside this function, and then our ways will be ways into the combination, will give us the total ways in which we can build our string. Okay, next check is if ways is greater than equal to limit, then return the limit. This condition is basically used to prevent the overflow, and after this condition we have to update the number of processed characters, that is used characters. Used plus is equal to count. Then then we need to return what? The function is count the ways. So we need to return ways. Okay, this function is complete. Now we'll move to the other function, that is ncr, private long. When you deal with multiplications and stuff, no, factorial and all, you better use long, because you can't predict how big the product can be. So to be on the safer side, it's very essential to use long. Here we pass n, r, and then the limit. Okay, now what is our r? R is minimum of our NCR is equal to NCR minus 1, right? Because see, the formula is n of c of n comma I is equal to c of n comma I minus 1 into n minus I plus 1 divided by I. So it's a very lengthy formula, and we need to use smaller values to reduce calculations. So we use r is equal to math dot min of r comma n minus r. This is basically because ncr is equal to ncr minus n minus r. So we prefer choosing smallest value to reduce calculation. That is why we are using this. And then we'll initialize long with ans is equal to 1, because we are dealing with multiplication. So we'll keep it as 1, because when you are multiplying something, if you initialize that to 0, 0 multiplied with anything else will be 0. So don't take that risk. Then we'll have to calculate NCR step by step. Int I is equal to 1, I is less than or equal to r, and I plus plus. Then what you have to do is calculate the combinations with the formula that I mentioned earlier, which is c of n comma I is equal to c of n comma I minus 1 into n minus I plus 1 divided by I. So how do we write it over here? Ans is equal to ans into, let's put a bracket, n minus r plus I divided by I. Okay, and then inside the for loop only you have to write if ans is greater than or equal to limit, which is great, then return limit. Else, if it's not greater than or equal to limit, then we need to return the answer. Okay, moving on to our main function, that is this. Okay, we checked if the count ways is less than k. If it's less than k, then we were supposed to return an empty string. Else we are supposed to store the kth smallest left half. So we'll use a string builder. Left is equal to new string builder, like this. And then we'll use a for loop from position 0 to the length of the left half. Okay, this is because fill every position with the left half. To fill every left position with the left half string. So int, let's say I is equal to 0, I less than len, I plus plus. Then if frequency of what was the variable that we defined? No, we did not define any variable. No, we are supposed to move across the, what do you say, the 26 characters, right? We didn't initialize that. Let's say int c is equal to 0 and c is less than 26, c++. Okay, so the frequency of c, if it's equal to 0, then you just have to continue. Or else you have to decrement the frequency because you have already used that character. So c minus minus. Alright, this condition is done. Now again calculate the ways possible. Ways is equal to count ways of frequency comma k. Okay, again if ways is greater than or equal to k, then left dot append character of a, it's a character, right? A plus c. Okay, this much is clear is what I believe. Wait, why am I feeling we left out some of the brackets? Yeah, this bracket is left out. We forgot to put the bracket. It should continue till here. Okay, fine. Now we have appended that character to left. Now once that's done, then we need to break, right? Only one character at a time will be appended, not much. Yeah, it's a if, so it's fine. Add the selected character to the left half. The character is selected, so move to the next position. That is what this break does. So in one position the character is fixed and you have to move to the next position, so you use break. Okay, then we have to skip all the arrangements beginning with this character. How do we do that? By minusing k from base. Okay, now frequency of c plus plus, because you have removed that character from the block part of the string, left half string, right? So you have to return the frequency back, and then we'll need one more string builder. Let's name that string builder to be, say, string builder ans is equal to new string builder. Okay, then we need to append that answer with the left. Okay, this much is done. Now if n divided by 2, that is the length of the string, is odd, then ans dot append the middle character. Now how to calculate the middle character? That is s dot char add n by 2. Okay, now this is done. Now we need to append the right half, right? That is ans dot append new string builder left dot reverse and then we need to return the final answer in the form of string. That's all. Now let's see. The solution was quite long and that's the reason. Oh my god, okay, we forgot to write the comma. The 27th line, okay. 34th line. And the 40th line. Okay, here we forgot to make this caps. And then anywhere else, can't find symbol. Okay. Count is not found. Count, oh no, count is not there. We forgot to initialize count or what? Wait. Let me read the problem properly. We made a variable mistake over here. See, for I in frequency, what does it do? It's basically used to traverse the frequency of all the 26 characters. And here you're ignoring whatever has, ignore unavailable character. Like in frequency array, we have 26 characters, and whichever is not present in a string, that will be named, its frequency will be 0. That is what we are ignoring over here. Now what has happened is we have named, this is count actually. Okay, this is count, the frequency count. We should have taken it as I, but we took it as count. It's fine, now it's correct. Okay, thank God. Now let's submit the answer. Now let's talk about the time complexity. Time and space complexity. The left half contains at most n by 2 positions. At every position, we try at most 26 lowercase characters. We have seen that in our problem. And so, with efficient capped permutation counting, the time complexity is big O of 26 into n. But since 26 is a constant, we don't consider it, and our overall time complexity becomes big O of n. Yeah, as the reason is mentioned over here, we process characters and construct the palindrome linearly. So this is the time complexity. Now moving forward to the space complexity, we store the frequency array, the left half, and then final answer, right? Therefore the space complexity is big O of n. Thank you, that's all for today's video.